All right, we're going to talk about how to solve right triangles. And what that means is you want to find all the missing sides and angles. I've got an example for you right here. And before we start solving, I want to talk about how to label these sides. Now, the side that is across from angle B, we want to represent that with a lowercase b. And the side that is across from angle C, we want to call that little c. And so the side across from angle A, we want to call that little a. That will help when you are starting to identify the pieces that you need to find. And I know there's a test question or something out there where that is used, so we needed to talk about that. All right, so if we're going to find all the missing sides and angles, what things do we need to find? Well, we need to find what the length for side B is. We need to find the measure of angle A and angle B. Does it matter what order you start this in? Absolutely not. I think I want to start by finding angle B. So I'm just picking one. Now this problem is a little bit different than some of the other ones that you will do in that you're starting with two sides, but the same type of process is going to be used in all of them. You're going to identify what you're missing and then just pick which one you want to start with and go from there. So for angle B, there's not a theta labeled here. So I'm finding theta. We're going to treat it like our theta. Now angle B, we know that its adjacent side is 3 and the hypotenuse of the triangle is 8. So adjacent and hypotenuse, that's the cosine ratio. We're going to use that to find the measure of angle B. Let's fill in what we know. We don't know the angle, so we're going to leave it there. But we do know that adjacent side is 3 and the hypotenuse is 8. So when you get to this point in a right triangle question and you do not know the angle, we can't just use the regular old cosine button because the calculator's programmed to tell you what the ratio is for a cosine, angle, sine, tangent, whatever. If you want to do the opposite of that, you've got to look on your calculator. And I know you really can't see it, but I'm going to try to get it where you can see it. Okay, so you've got the sine, cosine, and tangent buttons, but you've also got these in green above it. And that is an inverse cosine button. That's what you need to use when you want the calculator to tell you the angle that has that ratio. So we're going to do second cosine of 3 over 8. You can use a division key, you can use a fraction bar, it doesn't matter. But it comes out as 69.97. And for rounding purposes, if I round to a tenth, it really just makes more sense to say 68 degrees. So I'm going to leave it at that. Now that was for angle B. So if angle B is 68, we're done with that one. Okay, so this is 68. Now, if we know that angle B is 68, angle C is 90, how many degrees is that? That is 158 degrees between these two angles. 180 total in a triangle. So to find the measure of angle A, you can add the two angles that you know and then subtract that from 180. And that'll tell you the measure of the angle that you don't know. So that's 22 degrees. That'll be angle A. So we've gotten these two found. All right, so now we got to find side B. And again, I could have started with side B and found B and then A or whatever order you prefer, but you just got to start somewhere. So let's find side B now. All right, they're zoning in on this one. And let's see. We know this side is 3. We could either use A or C. Let's just go with this side in relation to this angle. All right, I could approach this from a lot of different ways. Actually, we could use a ratio here, or, better yet, let's not even do that. If we know two sides of a right triangle, we can just use Pythagorean theorem, right? So A squared plus B squared equals C squared. We're going to find side B here. Yeah, so you don't have to use those ratios. You can just do the old Pythagorean theorem. It works. All right, and this is nice because if you have your A, B, and C sides labeled and they're labeled correctly, you can just plug those into the formula as they are. So let's do 64 minus 9. That's a 55. Square root of that in a decimal format is about 7.4. Now, could you have left it as square root of 55? Absolutely. But in context, we usually like a decimal version, so either one of those is good. So when the question says to solve the triangle, you're finding everything. But in some of the questions, I'll only ask you for an isolated value, like an angle or a side. You don't have to do all of that in those situations, only when it asks you to solve the triangle. Alrighty, so I talked a little bit about angle of elevation and depression today, so I just wanted to kind of review that, especially if you weren't here. You probably need a little direction on that. So I've got a cat and a dog here, and the dog is looking up at the cat. This horizontal here, imaginary horizontal line, made with the line of sight, these two lines form the angle of elevation. So the dog's looking up at the cat. That's an angle of elevation. So that's the dog. On the other hand, you got Mr. Kitty Cat up here who is looking down at the dog. And the horizontal here, made with the cat's line of sight, that is the angle of depression. So just as the word kind of alludes to the direction of how someone is looking, you know, up, elevation, down, depression, that's exactly what it is. The thing to keep in mind is that it is always made with a horizontal and the line of sight. So the angle of depression, it looks like an upside down triangle if I were to draw the connection between this horizontal and the dog. Never make the angles with the vertical. It's always an angle made with the horizontal. So keep that in mind. Okay, so I'm going to do one problem down here at the bottom. And I'm going to move it over here so you can see what I'm working out. This is a problem we did in class. I'm going to redo it. It's at the bottom left of your screen here. So we've got a lighthouse, and you're given some information about it, but the only thing that is really relevant is the second sentence when it's talking about how far the lighthouse rises above sea level. It says it's 75 feet above sea level. Now, sea level, the elevation is 0. So if this lighthouse is 175 feet above sea level, it means it is exactly 175 feet tall. So we've got a lighthouse here, and then we want to know how far from the shore is the motorboat or a motorboat. So here's our unknown. If the angle of depression from the top of the lighthouse is 13 degrees. So we're making a little bit of an assumption here that the lighthouse makes a right angle with the sea level. And then we want to find out how far is the boat from the shore if the angle of depression is 13 degrees from the top. Well, technically, I'm given this piece of information because remember, an angle of depression is made with the horizontal and the line of sight. So if someone was standing on top of the lighthouse and they're looking down at the boat, that's a 13-degree angle. Well, I've already got a triangle drawn, and that 13 degrees is outside of my triangle. So remember, or let's just talk about this. If you've got a line of sight and with an angle of elevation and depression, what should be true about these angles if the cat and the dog are looking at each other? They'll be the same. So this angle of depression is the same as an angle of elevation of someone who's standing or in this boat looking at the top of the lighthouse. So we're going to use that angle instead of this depression angle because they are the same thing. And it's easier because, you know, it's not an upside down triangle and we can just leave it how it is. So according to this angle, we've got the opposite side is the height of the lighthouse and the adjacent side is the one we want to find. That is a tangent problem. So we're going to use that ratio. We know the angle is 13. And then the opposite side is 175. The adjacent is the x, the unknown. And what you want to do is multiply both sides by the denominator of this fraction, no matter what it is. Because that is the goal, is to get rid of that fraction. Because probably, more than likely, when a situation like this, now the problem we did originally at the top, I wouldn't do that. But if you've got an x on this fraction, you've got to get that fraction to go away. So multiply by the denominator on both sides. Now when we get here, we can see that x is not isolated, and that's the name of the game. So if it's x times tangent 13, we want to divide both sides by the tangent 13 degrees. Use that and put it in the calculator, and we will get an answer. of 758. And we want to label this with the units, and that would be feet. All right, so we're 758 feet away from that lighthouse on the base, at the base of the lighthouse. All right, if y'all got questions, let me know.